Okay, in this presentation we are going to look at continuous random variables. So here we have a continuous random variable with the probability density function given as follows. F of x, small f of x, equals cx squared, where the absolute value of x is less than or equal to 1. Or in other words, x is between minus 1 and 1, okay, and 0 otherwise. So essentially this is the key range of values that we'd be interested in when we do definite integrals. So we can disregard anything outside that interval because it will integrate to 0. Okay, so find the constant c, that's question A, find the expected value of x and the variance of x, and then find the probability of x being greater than or equal to 1/2. Okay, so part A. So to find c, what we do is we would use this identity here. Now this is sort of common to all continuous random variables. When we integrate the probability density function from the lower limit to the upper limit, or minus infinity to infinity, that should give us a value of 1. Okay, so 1 equals the integral from minus infinity to infinity of the probability density function with respect to x dx. Okay, now what we can do there is we can just switch the integral to what we are interested in, the interval that we're interested in, minus 1 to 1, because anything outside that interval is automatically 0. So we could just concentrate on what's inside that interval. So essentially what we have here is a definite integral from minus 1 to 1 of cx squared dx. So that's, we'll just bring c outside. That is x cubed over 3 from 1 to minus 1. And that is c times 1/3 minus 1/3. Okay, so the two minuses cancel out, so that is c times 2 over 3. Okay, so 1 equals 2/3 times c. Okay, so that means that c necessarily is equal to 3 over 2. Now the second thing is find the expected value of x. So we do something similar here. The expected value of x equals a definite integral. Here, rather than the probability density function, it's x times the probability density function. So that's x times x squared. What we could do actually is bring c outside the expression, or c outside the expression, 3 over 2 outside the expression. So we'll just disregard that for the time being, have the 3 over 2 there. X cubed, the integral of that is x to the power of 4 over 4, and we evaluate that from minus 1 to 1, and that is 1/4 minus 1/4, which is 0. So what we end up with here is 3 over 2 times 0, which is 0. Okay, now we got to guess that actually. The reason is that the probability density function is symmetric around x equals 0. That is to say, it's an even function, okay? Sorry, an odd function on a symmetric interval, okay? So an odd function on a symmetric interval, automatically that's going to integrate to 0, okay? So that's good. So what we can do now is get the variance of x. Okay, so that is the expected value of x squared minus the expected value of x to be squared. Now that is automatically 0, so essentially all we have to do is find the expected value of x squared. Okay, so the expected value of x squared, which is also the variance in this case, is the integral from minus 1 to 1 of x squared times the probability density function dx. So that is, again, we bring the 3 over 2 outside and we'll just concentrate on what's left inside functions in terms of x. So it's x squared times x squared. That's x to the power of 4. So when we get a definite integral of x to the power of 4 from minus 1 to 1, that's x to the power of 5, x to the power of 5 over 5 from minus 1 to 1. And that is 1/5 minus 1/5. Or in other words, 2 over 5. Okay, so the expected value of x squared equals 3 over 2 times 2/5, and that will give us our answer there, 3 over 5. Okay, so let's just sort of clarify that. It is 3 over 5. That is the answer to that one there. Okay, so that's also the variance of x. So the variance of x equals the expected value of x squared equals 3 over 5. Okay, finally, find the probability of x being greater than or equal to 1/2. Essentially what we do here is we evaluate the definite integral of the probability density function from the lower bound of this interval to the upper bound. Now the upper bound here is the maximum possible value. So in this case it's 1. So it's 1/2 to 1. That's a definite integral of x squared dx. Okay. So what we have here is definite integral of x cubed from 1/2 to 1. Not forgetting our 3 over 2 here. So that is 3 over 2 times 1/3 minus 1 over 8 divided by 3. Okay. Then that is equal to 3 over 2 times 8 over 24. So just re-express 1/3 as 8 over 24 minus 1 over 24. Okay. And that is 3 over 2 times 7 over 24. And that works out to be 7 over 16. Well, it actually works out to be 21 over 48, which is 7 over 16. So that's our answer there. That is the probability of x being greater than 1/2. 7 over 16. You can adjust that, express that as a real number if you want. Okay, that's it.